Alright guys, so today we're gonna be coding a simple website example just to teach the basics of HTML and CSS and linking CSS files to HTML and having links inside of HTML files. So we're just gonna call it Sweet Surrender Bakery. And the title is just what it's gonna show up as in the tab of the window. And I started using WebStorm by JetBrains because it just has a lot of nice defaults, I find. Like even doing copy path and stuff, or delete, you consider like references in other files for that file when you delete it and stuff like that. Refactoring changes across multiple files. There's just a lot of things that make it really convenient to use to edit, but you can achieve similar things with VS Code, just using extensions and stuff. It's just that this kind of just comes ready to go. Though it's not perfect, it is a little on the heavier side in terms of how much RAM it takes up, I would say. For my MacBook, I only have like 8 gigs of RAM, so that is something I experienced. But I mean, besides that, I feel like I like to use it a little bit better than VS Code. I feel like it's a more well-rounded product, but yeah. So UL is an unordered list, LI is a list. Also, this is not sponsored by JetBrains or anything. Just a disclaimer. Anyways, A is an anchor tag. The href is going to be the link that it points to. So right here, we're just creating a little nav bar. So the nav element is the nav bar, and then the div is it's like a division. It's like a section of the page. The best way I can describe it, like think of it just like a rectangle or something. You say that is the div. So yeah, inside of UL or OL, which is an ordered list, you have to put LI for every list element. And then what shows up between the two the brackets thing, what's that called? Like I put just about, you can see that that's what the text is for that element, and then when you click on it, it is redirecting to the link. This isn't the so the internet can be thought of like a big city. At the center, websites are like skyscrapers, each with information, entertainment, services. But how are they built and kept running or made accessible to everybody around the world? So before we dive into the specifics of this, it's important to understand that the foundational infrastructure that makes all of this possible is the internet itself. The internet is like the city's network of roads, highways, communication lines. Not a single entity, but a global network of interconnected networks, like the Wi-Fi signal, I don't know, towers, and then satellites. It's a lot that goes into it, but like websites are hosted on servers and they communicate with a few different devices before they get to your device. But at the heart of this network are routers. Imagine routers as traffic controllers at major intersections directing data packets. Tiny digital envelopes containing pieces of information to their closest destination, correct destinations. These packets travel across various pathways, hopping from router to router until they reach their intended server or your computer. Each device connected to the internet, whether it's your smartphone, laptop, or a web server, has a unique address called an IP address. This IP address is like your home address in the digital world, allowing other devices to locate and communicate with you. When you type a website address like www.google.com in your browser, the internet's equivalent of a postal service uses the domain name system to translate this human-friendly name into the server's numerical IP address. So yeah, as from before, we just have H1 as the header about us, just creating a simple example page for a bakery. P is a paragraph, like just text, but you'll notice that some of the formatting inside of that doesn't necessarily carry over to the actual element. Like, we have a new line after cakes in our first new line, or after our first line, and then on the site you can see that, the file, viewing it in the browser, the new line shows up after handcrafted, so that's more based on the width of the actual device used to view it. It's going to look better after some CSS styling, so yeah. Each device connected to the internet. Now let's zoom in on where websites actually reside. In our city analogy, websites are like buildings, and web hosting is akin to leasing the land on which these buildings stand. Web servers are the plot of the land itself, powerful computers constantly connected to the internet, acting as storage and distribution centers for website files. When someone creates a website, they need to find a place to host it. This is where web hosting providers come in. These companies own and maintain vast arrays of servers housed in secure data centers. They offer different hosting packages, essentially renting out space on their servers to individuals and businesses who want to make their websites accessible online. If you want to open up a shop in the city, example like the bakery, you could build your own building and connect it to all the city's utilities. Example, setting up your own server, complex and expensive, very time consuming. Or you could rent a space in an existing building, and this is akin to web hosting, where the landlord or hosting provider takes care of the building's infrastructure, security, and connection to the city's network or the internet. When you visit a website, your computer sends a request across the internet to the web server where the website is located. The server then responds by sending back the website's files, code, images, text, and everything else that makes up the site, which your web browser then interprets and displays on your screen. To facilitate this communication between your browser and the web server, a specific protocol is used, HTTP, or Hypertext Transfer Protocol. HTTP is the language of the web, the set of rules that govern how web browsers and servers exchange information. Imagine you're in a restaurant, your web browser, and you want to order food, request a web page. You use the restaurant's menu, HTML, to decide what you want. You then signal the waiter, HTTP request, who takes your order to the kitchen or web server. The kitchen prepares your meal, processes the request, and retrieves website files, and the waiter brings it back to you. Also, HTTP response. You then enjoy your meal, or your browser displays the web page. So this can be thought of in 4 parts. A request. The browser sends an HTTP request to the web server. This request specifies what web page or resource you're asking for. 2 is processing. The web server receives the request and processes it. This might involve retrieving files from its storage, running server-side code, or querying databases. 3 is response. The web server sends back an HTTP response to your browser. This response contains the requested content and a status code indicating whether the request was successful. 4 is rendering. Your web browser receives the HTTP response, and if it contains HTML, it interprets the HTML code and renders it visually on your screen, displaying the web page with text, images, links, and styling. Crafting the blueprint, making HTML files. Now that we understand the underlying infrastructure, let's delve into the building blocks of websites. HTML. HTML is the structural foundation of every website you see. It's not a programming language in the traditional sense, but a markup language. Think of HTML as the blueprint of a house, defining the rooms, walls, and structural elements. HTML uses tags to structure content. Tags are keywords enclosed in angle brackets. Most tags come in pairs, an opening and a closing tag. The content between these tags is what the tag describes. In our page, you can see the doc type HTML. This declaration tells a browser that the document is an HTML5 document. It's always the first line of any HTML file. HTML lang equals en specifies the language as English, but it can be any language. Head is meta information about the HTML documents, such as the character encoding, the meta tag, which has name, content, initial scale, configures the viewport for responsive design, making the website look good on different screen sizes, such as a phone, tablet, or a desktop computer. Title is the page title. This is what appears in browser tab or window title bar. Link rel style sheet, href style CSS. This links to a CSS file. Which styles the HTML content. And there's a different way to link JavaScript files. You do script equals script.js, I think. Script src equals script.js for JavaScript. But for now, we're just going over HTML and CSS. So JavaScript will be covered in a later video. Because it's important to get the basics of HTML or CSS before moving on to JavaScript. Because that's where the majority of your coding will be done, actually. If you're planning on continuing with web dev. Because JavaScript will facilitate a lot the logic of a file and there are various front-end frameworks like Vue or React. There's also Angular, which is not just a front-end framework. I think Vue and Angular both have a lot of tools for not just front-end, but also for back-end. But React is primarily front-end. But React is the most in-demand. React is made by Facebook, I'm pretty sure. Vue, Angular, I think Angular is by Google, and then Vue is the latest, which like Angular came to fix React, and then Vue came to fix Angular, something like that. The JavaScript ecosystem is constantly evolving. Nothing really stays the same. It's a field with a lot of developers and just a fast-moving pace, I would say. A lot happens in a short time. sections like we've seen here. It's similar to div, but it's a semantic element that represents a thematic grouping of content, similar or typically with a heading. It's used to structure the document into logical sections. So yeah, we have divs inside of our sections, and inside of divs we have label, text area, or input. As you can see for the label, we have for equals email, and then in the input we would have type equals email. So that's how the browser knows that the email label is for the email input area. When you specify the type of input, it'll usually have certain requirements, like email would have like @example.com or something like that. If it doesn't have that, it knows it's not an email. Forms are used to get information from the user. Right now it's not really being used in that way. It is just to show example functionality, which yeah. The button element creates a clickable button, often used to submit forms. Anchor tags connect different parts of your website and linking to external resources. They're the anchors that hold the website together, the web together. Styling the web, CSS basics. So while HTML provides a structure, CSS, which stands for Cascading Style Sheets, is responsible for the visual presentation of your website. It's a look and feel. CSS is like the interior design and decoration of our house analogy, determining the colors, fonts, layouts, and overall aesthetics. CSS works by applying styles to HTML elements. You can target specific elements or groups of elements and define their visual properties. CSS uses a simple syntax based on selectors, properties, and values. A selector identifies the HTML elements you want to use, property, the visual characteristic you want to change, value, the setting you want to apply to that property. Like body here is the selector, and select elements inside the body. So under the head and properties, this will be like margin or padding. Value would be what comes after margin, the number 0. So there are a few different ways to apply CSS. You can do inline styles, which is applying styles directly within the HTML tags using the style attribute, which is discouraged because it does not lead to code that's as legible or clearly separated for each thing having a different function and being modular. Internal style sheets, embedding CSS code within the head section of your HTML file, suitable for smaller stuff, but external style sheets, which is creating a separate CSS file like we've done here, and linking it to the HTML file using the link tag in the head section is the best practice for larger projects, promoting code organization and reusability. And as you can see here, we have one style.css file, and it's applied to both of our HTML files, so you don't need to create a separate CSS file for every HTML file. Just one is enough for the entire site and all its pages. Learning HTML and CSS, tips and tricks. So Some tips to help you along the way is to start with the basics. Don't try to learn everything at once. Begin with the fundamental concepts of HTML elements and CSS properties. Focus on understanding the core concepts before moving on to more advanced topics. Practice regularly. Coding is a skill that improves with practice. Write code every day, even if it's just for a short period, or something small, like kind of like with drawing, like drawing one sketch a day or something like that. Similarly, even like a small amount of time invested will add up over time. Utilize online resources. The web is brimming with excellent resources for learning HTML and CSS. There's Mozilla Developer Network, MDN. W3 Schools is good for just viewing documentation, but shouldn't be the only resource you use, especially if you're trying to learn other languages as well. Free Code Camp is a good resource. Udemy, I would maybe if there's a sale going on, but yeah, I mean, you can find all of the information for free. You don't have to pay for anything to learn it, but it's honestly up to you. There are some good courses, but yeah, I mean, I guess just think before you buy. I don't know what else to say about that, to be honest. Build small projects. The best way to learn is by doing. Start with small manageable projects like personal websites, simple landing pages, or portfolio sites. As you progress, tackle more complex projects. Inspect websites using developer tools. This is actually a pretty good one. Use your browser's developer tools, usually accessed by right-clicking on a web page and selecting Inspect or Inspect Element to examine the HTML and CSS code of existing websites. It's a great way to see actual web dev in real life around you, and to learn from how people structure their sites. Join communities, ask questions on forums like Stack Overflow, Reddit. GitHub, depending on if there's a comment-like structure available for what you're doing. Sometimes it's available, sometimes it's not, depending on where you are on GitHub, but I would still recommend backing up your code to GitHub because it's helpful, especially if you reset your computer or like to install different operating systems, or just if you want a record of all the code that you've done throughout a certain period of time. Whenever you upload it, like, you'll have it forever basically on GitHub or whatever service you choose to use. But GitHub is honestly recommended for people who are just starting out. It's really easy to understand and use, especially once you get the hang of it. I know I felt kind of overwhelmed when I first started like using GitHub to back up my code, and it kind of put me off of using it for like a year or two, but I'm glad I did get back into the habit of backing up my code, because I've reset my computer a few times and like installed different operating systems, and like throughout each time I don't have to worry about backing up my work as long as I regularly make commits on all of my repositories. My work is saved, so it's always nice to have. And also, you can view history inside of, so version control systems gives you access to history, and you can view different versions of the file. Say you make a change and you break something, then if you backed it up when you before when it was working, then you can just restore that using terminal command. You can also make a bash or CSH script to save yourself some keystrokes if you just do like git add period and then a few other things like commit /m and then git push origin main, and then like just have them all in a ZSH script where you can call that script and then you have a string after you call it, and that'll be the commit message. You can do all of that from just one line of code, which can be really helpful if you're just trying to back it up regularly. It can be kind of tedious to back it up and do all three, git add, git commit, and git push origin main, every single time you do the version control thing, like to back up your code. So yeah, definitely try automating things. It's also a great way to learn more about programming and just to think like a programmer, or like an engineer. It's a great way to get in that mindset. Alright, some do's and don'ts of HTML. So some do's is to use semantic HTML. Employ semantic HTML elements like article, nav, aside, header, footer to give meaning and structure to your content. This improves accessibility and search engine optimization. Write valid HTML. Ensure your HTML code is valid by using a validator or a linter. Valid HTML code is less prone to browser inconsistencies and errors. Use proper heading hierarchy. Use headings H1 and H6 in a logical order to structure your content hierarchically. Don't skip heading levels. Provide alternative text for images. Alt equals and then what it's the images of. Always include descriptive alt text for images for accessibility and search engine optimization. Organize your code. Keep your HTML code well indented and organized for readability. Use comments to explain sections of your code when necessary. HTML don'ts. Don't use HTML for styling. HTML is for structure, CSS is for styling. Avoid using HTML elements or attributes for purely visual purposes like font tags or inline styles for complex styling. Don't use table-based layouts. Tables are for tabular data, not for website layouts. Use CSS layout techniques like Flexbox or Grid for creating website layouts. Don't write messy or unindented code. Inconsistent indentation and disorganized code make it difficult to read and maintain your HTML. CSS do's. Use external style sheets. Always use external CSS files for larger projects to keep your styles separate from your HTML and improve code organization and readability and reusability. Write clean and organized CSS. Structure your CSS code logically. Use comments to explain sections of your styles. Group related styles together. Use CSS selectors effectively. Learn to use different CSS selectors like class selectors, ID selectors, element selectors, combinators to target elements precisely and efficiently. Embrace responsive design. Design your websites to be responsive, meaning they adapt gracefully to different screen sizes, desktop, tablets, and smartphones. Use media queries in CSS to apply different styles based on screen width, and prioritize accessibility. Consider accessibility when styling your website. Ensure sufficient color contrast. Use semantic HTML and provide alternative text for images. Validate your CSS. Use a CSS validator like W3 School or CSS validation service, or it's jigsaw.w3.org/CSS validator to check for errors and ensure your CSS code is valid. Use CSS frameworks and libraries, but wisely. Frameworks like Bootstrap or Tailwind CSS can speed up development and provide pre-built styles and components. Use them judiciously and understand their underlying principles. CSS don'ts. Don't overuse inline styles. While inline styles have their place, excessive use makes your HTML cluttered and styles harder to manage. Don't repeat styles. Avoid writing the same CSS styles multiple times. Use CSS classes to apply styles to multiple elements, and keep your code dry. Don't neglect browser compatibility. Test your website in different browsers, Chrome, Firefox, Safari, Edge, to ensure consistent rendering. Safari uses WebKit, Firefox uses their own engine, and most other browsers are built on Chromium. Don't create overly complex selectors. Keep your CSS selectors as simple and specific as needed. Overly complex selectors can impact performance and maintainability. The importance of good code beyond just aesthetics. Making sure it's user-friendly. Well-structured HTML and efficient CSS contribute to faster loading times and a smoother user experience. Accessible code ensures that websites are usable for everybody. Maintainable and scalable. Clean, organized, and semantic code is easier to understand, update, and expand upon. This is crucial for long-term website maintenance and growth. Search engine optimized. Search engines like Google rely on well-structured HTML to understand the content and context of web pages. Semantic HTML and proper heading usage can improve your website's search engine ranking. Professional and credible. Well-coded websites reflect professionalism and attention to detail. They build trust with users and enhance your online reputation. In essence, writing good code is about building robust, accessible, and future-proof websites that serve their purpose effectively and provide a positive user experience for all users. It's about crafting digital structures that are not only visually appealing, but also structurally sound and built to last. Conclusion, your web development journey begins. This journey into the world of web hosting, HTTP, HTML, CSS, has hopefully illuminated the intricate processes that bring websites to life, from the vast network of the internet to the precise lines of code. Each component plays a vital role in shaping our digital experiences. Learning HTML and CSS is your first step towards becoming a web creator. By understanding the fundamentals, practicing consistently, and adhering to good coding practices, you can build your own corner of the internet, contributing to the ever-evolving landscape of the web. Remember, the web is a constantly evolving space, and the journey of learning is ongoing. Embrace the challenge, experiment, and never stop exploring or learning. So yeah, thanks for watching up to this point. REM is relative to the size of the page, or I mean the viewport. No, it's to the page. REM stands for root M, always relative to the font size of the root element. So this means that 1 REM is equal to the computed font size of the HTML element. Doing the hashtag in front of a selector for HTML selects the ID. Doing a dot would select a class. You can select multiple. Like, here I have the ID for contact info, the class contact details. Yeah. All right, well, thanks for watching, and I'll see you next time.